Hi, Nick. No, you're fine. You won't be good. No. So see, even Mickey moving there made that flame go chalkboard-wise, as we say. 3, 2, 1. Oh. 3, 2. Yeah. So, Charles, can you relight the candle? Are you maybe we should wait. No, go ahead. So here's the thing that you might intuit or think at first is the air coming out of a primitive thing like this would be, what would be the shape of the air? I mean, I've just talked about vortex rings and stuff, but you might think it would be a ball or a sphere like the horse coming out. You might think it would be a bullet shape, like a round nose with a truncated or cut off tail. You might think it would be snake-like or something. But using this giant freaking fog machine, we will now, I believe, show you the true shape of the air that comes out. Now, bear in mind, this is not continuous flow. I'm going to give it a pulse, right, with the shower curtain. Thank you. This is theater fog, and I've been breathing this stuff. It's sort of made of boiled soap, I mean. I've been breathing this now for 30 years or something. And you can see I'm fine. All right, so this is the true shape of the fluid as it comes out of the nostril. Whoa! That's just not cool. So, yeah, I was going to shoot out this one. So let me get it a little stronger one. Yeah. So you can see it. Oh, there, for Charles, yeah.
Thank you.
So you can see also. You can see also just how much inertia it has. I mean, this is not a wave, right? This is fluid moving through fluid. And you can see, I think, pretty easily the spiral nature of it, so that it looks like it's a ring. Yeah. Slow motion charge. Grabbing ring. So in the best case, I will demonstrate, this is in the best case, a ring passing over the candle without the candle going out. Okay, that is our goal. What are we doing? Oh, reloading? My assistant, yes. It's reloading. Charles, you know, they sell more cardboard boxes, and so I'm handling this kind of going, bleeding out. Thank you. But it's still in service, yes. So we're going to try to get a ring to go right around the candle. I can't see a thing, so that's good. You see there right here, it was adhering to the duvetine, to the black surface. As when I went over the candle, try to go, and just see how it interacts with the surface. They're just gorgeous, man. Yeah, man. So a little higher, steady, too high. So I'm probably just watching, I'm probably going to hit it with the ring. And the airspeed is the highest in the ring itself. And what makes the candle go out is when you cool it off really fast. So the airspeed, the swirling fluid in the ring is what cools the wick off so fast when you blow on a candle. Yes. Oh. Maybe. A little more power.
No, thanks, I don't.
What? There's an interaction with this. I'm not kidding. I made a modification to downrange smoothivity. Now I got to flatten the thing. I'm gonna, this table. I'm gonna hold it. Freestyle. Well, you see how seriously the ventilation in the room influences the path of the wind. Tuition at work. Yeah, okay, cool. So now now, thank you, Charles. Professor Williamson reminded me of some cool things that are really intriguing to watch. And this is where most people just, I don't really appreciate how complicated fluid flow is. So what we'll try to do is get one ring going and then catch up with it with a second ring, and then just cool interaction. And so a lot of times you can get them to go. Here, let me aim up where you can all see it, because it was working. Oh, whoa. Ow! Got me in the face. Steady, Mickey. Take a man's leg up. But you see,
crazy. I can feel it blowing my hair.
Yeah. So you see how they interact, and there, it makes a Y shape.
Take a refill.
Refill. Give me a jolt. Anyway, what'll happen is they'll interact, and neither one of them will, like billiard balls, they'll both change direction. See how they, I don't know if you can see, they went Y-shaped. So with one, and they spread away this way. So now he's got a commercial product called the Air Zuka. And there, see how they pushed each other apart? And it's this thing, it's not a wave. It's this other deal where the fluid is moving through the... Oh, it's just sexy. Oh, come on. It's just, God, that's really fluid mechanical. Yeah. So then what will happen, Charles, Professor Williamson is about to talk about this. There'll be an interaction that's often a polygon. You'll get 6-sided figures, 8-sided. Oh, did you see that? Did you see where they, they split apart, yeah. And so what will happen, that any instability, any air conditioning flow it encounters between here and Nick or Charles will cause this polygon to form. It's hard to see, but once in a while you'll see a picture. What do you need? More smoke? This is your tuition dollars paid for the smoke machine. Thank you. Thank you. Cool. Oh, yes. It's just so much fun. Now, we may need more light back there. Appreciate that. Now, see how far they'll travel? Well, it's the price of science. So the other thing about these rings to me that is really always appealing to me, you can do a lot of analysis of flow of fluids and stuff, but at some point just appreciate their beauty. I mean, there's something about them that's just wonderfully intriguing. And you see also another thing we take for granted in life. Just look at all the air currents in just this one room. And just imagine if you're a butterfly or a bird trying to make a living. You've got to deal with all these crazy tiny flows. Yeah. So, thanks. So Charleston, you had an Air Zuka concept, yeah?
Yeah, we were just thinking, what would be the interaction with the Air Zuka?
So the Air Zuka is, it's not as precise as the cardboard box, but it is another thing that really, for its volume, produces a tremendous amount of a big puff. So Nick, are you going to flap the Air Zuka?
Oxford is going to destroy some of the...
Oh, really? Okay, so in mid-flight, Oxford's going to take out some of the
some revenge from that international snuffing tank.
So I know every day isn't like this. Let's see, come on. See, he's just not hitting. There you go. You caught the edge of one.
Man, I just can't get these.
No, you just can't get them.
There we go. I've got a laser on this thing. You better watch out. You're on there. Thank Darcy.
I took fluid mechanics, okay, it wasn't like that. It sucked. I guess that's a fun. That's a good one. Yes. So this is a productive use of an hour.
Cups underneath your seats. Put them on your head. See if you can.
So you put them on your head. So time. Can somebody lend time? So she can't get up until she puts on the microphone. She has no battery. What was that? So here's the idea. Well, we got to replace the battery. By the way, if you guys can invent a better battery, get rich. And it wouldn't surprise me to find out that what we need are liquid metal batteries. These would be batteries with molten magnesium, a layer of sodium chloride or calcium chloride salt, and then a layer of antimony, or antimony, the element next to tin on the periodic table. And so, Tyne, if you would go down there and like so many people, put a cup on your head. That's pretty far off.
Yeah. That's good.
So this is what you can do instead of whatever else you'd be doing on weekends. You're pretty close now. Can you back up a little bit? So what is striking is this woman's posture. It is otherworldly. Back up a little. I mean, this is really at this range. So now, productive students paying a fortune to go to Ivy League school, we will now more power. 2 at once. Yes, double shooting. Yes. 2 at once. Yes. Yeah. So, you know, this box has been in service a long time. There. He was wearing safety glasses. No, so this box is, pretty good for the first couple rows. But it gets out there. Did you see that one jump? Because it got in this motion of the ring, the radius-wise radial motion of the ring lifted it off his head. That was pretty great. Or her head. Yes! This is good. But now, we're going to take it up a notch. So this one here, can you turn it? Can you show the other side to the audience? This one has been modified so that you can, you guys familiar with Trip Hammer Road? Yes. So there used to be a big company in town called Ithaca Gun. They made apparently very high quality guns. But what you would do with a gun is you have to cock it. You have to load it. And so you pull this back, and it's got a bungee and elastic inside to produce a lot of power. Yes. So ladies and gentlemen, let's go down this row and see how many we can get with one whack. Yes. Yeah, okay. I wonder, let's just try this first one. Okay. 3. Okay, you guys, you're holding it steadily? 3, 2, 1. Let's go slightly camera right. Slightly up. 3, 2, 1. I mean, this is cool. Okay, we're going after Mickey. So you guys, it really did hurt my knee very badly Monday. I stepped on the cuff of the fancy dance slacks and tore my tendon. So we're hopeful, Tyne and I are hopeful that we can stay in it. I will be a robot if I don't hurt my leg again. Are you guys coming over to your reload again? So please vote for Team Hot Knowledge. Because everybody likes it, though. You guys, let's go to your left uphill just a little bit. Yeah, let's see how many we can get. Can you take the trash, the precision vortex slightly closer to the, so I can pull that through. All right. 3, 2, 1. It shows you how accurate you really have to be.
Guys, get forward so Bill can get more bigger run out.
One more?
Yeah.
A big run up. Yeah, really.
Yeah.
Okay, so I can come way back here.
Yeah.
3, 2, 1. Blue paper cut. You guys,
We have just one last little surprise for you.
oh, we do. Oh wow, this is from a time. Another annihilator, get it? That's hilarious. So what are we gonna do? We're gonna have a ring off.
You're going to break your vortex.
Okay, it's ring to ring. It's hilarious. Come on. And the word "nye" is anybody from Scandinavia or anything? It means new. And so when I go to Denmark or Norway, my name's on everything: laundry detergent, food. And so it's also New Year's Eve is NYE if you ever want to. Okay. And most places they say "me," but there's some dialects they say "nye." So all right. So it's going ring to ring.
It's going ring to ring.
So watch this interaction. It's really something. So, oh God, that was a nice one. Then you start. See how it went through the middle and then created a bigger ring? Oh. Okay, one more. Okay, this is it. Oh, yes! They passed right through each other. Even though they had instabilities, there's enough stability, enough inertia for them to, oh man, see it wobbling, boom, 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 boom. It's still stable, it still overcomes it. So this will be, how many questions on the smoke rings, Charles, on the exam, on the prelim? Whoa. Self-destruction. Yes! 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 You guys, I was in school here. I graduated with a class of 1977. And I'll just tell you, this university changed my life. Okay, and no matter what happens, your Cornell education will be with you your whole life. And I really appreciate that you guys took the time to come to class. There's more of you, I think, than normal. Is that right?
You're all going to have to take the exam though.
And your Cornell degree will be worth more a year after you graduated than it will be the day you graduate. And you have the opportunity, I'm not kidding everybody, to make the big changes, to come up with the big ideas that we need to feed and clothe and have a high quality of life for people everywhere in the world through using science to do engineering. And for me, engineering is two things. You solve problems and you make things. So I want you to get out there and, dare I say it, change the world! Like this. Professor Williamson.